this program, we will examine the systematic and objective approach of the scientific method. We will then discover how science and its faithful accomplice, technology, change how we perceive the world. And finally, we will take a look at what makes science and a belief like astrology irreconcilable. It's in man's nature to ask all sorts of questions. Faced with an inexplicable event, he will ask himself, who? Why? How? For a long time, scientists were also philosophers. In answer to a question like, why does a pebble thrown in the air fall back down to the earth? They might have responded, bodies inevitably seek to return to their natural environment. Such an explanation seemed quite suitable to them. Science as we know it today originated when men like Galileo began to observe events, to measure them, and base their theories on their observations rather than their desire to explain man's place in the cosmos. During the last few centuries, our knowledge of the world around us has progressed in leaps and bounds. For better or worse, we have learned to use our knowledge to predict and change reality as we see fit. The amazing advancement of science and technology cannot be attributed to an increase in human intelligence. Scientific discoveries were largely due to the generalized application of a simple method of work. Called the scientific method, it stipulates that order and principles shape the universe. Using this method, researchers can probe reality to determine that order and those organizing principles. The scientific method can be used to solve problems of all sorts. It encompasses a series of steps. The first consists of formulating the problem to be solved in precise terms. For example, what is preventing this car from starting? To define the problem correctly, the mechanic, like the researcher, must first examine the problem. The next step is to apply the knowledge already acquired in the field she is studying, or related fields. This can take a long time, given the enormous quantity of scientific knowledge already gained. The mechanic, again like the researcher, must also observe the object or the phenomenon of her interest attentively. Observation requires sharpness of the senses. In this particular case, observation steers the mechanic towards a more in-depth examination of the charging system. The car won't start, and the battery is dead. After having identified the problem, the next step involves coming up with a hypothesis. That is, a plausible cause of the problem. In order to formulate a hypothesis, the mechanic has to resort to a mysterious quality: intuition. Intuition enables the brain to simultaneously analyze a great number of observations and to establish associations between them. Here, several hypotheses are possible, and what guides the mechanic and the researcher alike to the most likely one is their intuition. The mechanic is therefore able to hypothesize that the cause of the problem is the alternator. Indeed, the alternator charges the battery. If it is defective, it would not charge the battery properly, and this would prevent the engine from starting. The next step is experimentation. The mechanic measures the flow of electric current and the voltage at the alternator's terminals. Like the researcher, the mechanic will attempt to verify her hypothesis and monitor the conditions of the experiment with precision. Both must be meticulous. A scientific experiment does not necessarily require sophisticated equipment. However, it is necessary that it be reproducible. When it is repeated, the experiment should yield the same results. This enables any person to verify that the experiment was conducted according to the rules. Once the experiment has been completed, the researcher then has to compare his results against the original hypothesis. If the results confirm the hypothesis, it is accepted. The absence of current in the alternator confirms the mechanic's hypothesis. It is at this stage that reason and logic come into play. Recognition does not necessarily mean a positive answer, but at least it enables a person to gain more knowledge. The mechanic will only receive firm confirmation of her hypothesis once she has changed the defective part. However, more often than not, the researcher will find his hypothesis was wrong. The same sometimes applies to mechanics. Even the non-confirmation of a hypothesis provides useful information that will enable them to formulate another hypothesis and to repeat the cycle again and again until they have found a solution. The last step in the scientific method consists of disseminating the new knowledge and the results of the work carried out. This stage is crucial since it allows other results to be added and, if need be, criticism to be formulated. It ensures that scientific knowledge continues to evolve, which is essential to science. Although it often requires complex and costly equipment, the scientific method consists more of an intellectual attitude than of a series of processes. That attitude is based upon rigor and perseverance. Although scientists sometimes make discoveries, it is often by chance. Science proceeds slowly, but surely. The scientific method is tried and true, but it seems to disregard an important factor: chance. Whether Christopher Columbus's discovery of America, we know he was looking for the route to India, or Fleming's discovery of penicillin. History is full of scientific discoveries that came about by chance. Influenced by chance or not, scientific discoveries and their technological applications contribute to changing our perception of the world. For a very long time, our ancestors believed they lived on an Earth that was flat and formed the center of the universe. In fact, observing the sky, we have the impression that the sun, planets, and stars revolve endlessly around us. If we were to rely solely on our five senses, it would be hard to believe that the ground we walk on is anything other than a vast slab. We now know that the planet is round and nothing more than a speck of dust in the immensity of the cosmos. During the past few centuries, our vision of the world has completely changed. We do not owe the changes to the power of our minds only. They should be ascribed to an increase in our capacity to observe the world. That capacity is based upon a host of instruments that have extended our senses. Our knowledge of reality depends enormously on the action of our five senses. The human eye, for example, is one of the most sophisticated in the animal world. With its adjustable lens, it can make out an object of 1.5 millimeters in diameter from a distance of 5 meters. Thanks to specialized cells that cover its sensitive retina, the eye can also recognize a great many colors. Our other senses are also very sensitive instruments. Thanks to our sense of hearing, we can perceive and distinguish up to 400,000 different sounds. Touch gives us information on temperatures, textures, pressure, and the degree of humidity of objects in contact with our skin. Smell and taste are our chemical senses. They can analyze a broad range of compounds in the air or in food, assess their properties, and identify them. While the five senses allow us to explore the world around us and to mold our vision of reality, they have their limitations. Instruments of observation invented in recent centuries have pushed back those limits. These tools extend the action of our senses in different ways. Some of them, like the telescope, increase their range. Whereas the naked eye can only distinguish about 2,000 stars, telescopes have revealed the existence of myriads of stars located millions of light years away. These instruments have enlarged the known universe immeasurably. Conversely, other devices increase our senses' power of resolution or their capacity to make out extremely minute objects or phenomena. For example, objects 1/10 of a millimeter in diameter are too small for the naked eye to perceive. However, the optical microscope lets us distinguish objects 100 times smaller, less than 1/1,000,000th of a meter in diameter. The electron microscope, which probes matter by electron beams, goes even further. Its power of resolution attains 1/1000,000th of a meter, allowing us to see molecules, even atoms. Images seen under microscopes have revealed the extraordinary complexity of inanimate and animate matter. These instruments of observation have all broadened the range of the phenomena we are able to observe with our senses. For example, the light rays we can perceive with our eyes are but a tiny fraction of the full spectrum of electromagnetic radiation. That largely invisible spectrum ranges from radio waves to X-rays, through microwaves, infrared, ultraviolet, and gamma rays. Other devices like the radio telescope, which listen to the sky, are able to pick up other parts of that spectrum and can even translate them into pictures. It's as if these instruments give us an opportunity to see worlds parallel to our own. Constantly being refined, our instruments of observation help us to gain more and more knowledge about the universe and ourselves. But today, scientists are beginning to see limitations, even in their sophisticated equipment. For instance, particle accelerators enable physicists to go deeper into the heart of matter than the microscope ever could. These machines are colossal, but to continue to collect new data, they will have to be made even bigger, more complex, and more costly. Increasingly, researchers are wondering about the validity of the observations made by their instruments. Indeed, our senses are frequently the victims of illusion. Each of our senses and every instrument of observation generates a vision that is a particular aspect of the same reality. Only the mind can assemble all the pieces of the jigsaw puzzle. For a long time, faith gave us answers, until science dethroned it. But religious sentiment did not disappear. Never before have esoteric doctrines had so many devotees or taken on so many aspects. Among these beliefs, one of the most popular is astrology. Now, at the risk of disappointing a number of you, research has never been able to prove any scientific premise for astrology. In spite of the indisputable progress science has enabled us to make in recent centuries, it has not, and probably never will, answer our most basic questions. Why are we here? What is our destiny? Many people have a hard time accepting this fact, so they turn to knowledge parallel to the sciences which attempts to make up for the deficiencies in scientific knowledge. Astrology is probably the most ancient of these pseudosciences. It assumes the existence of a relationship between the position of certain stars and, generally speaking, human activity. Astrologers are said to be able to describe and interpret those relationships. They supposedly can define people's personalities and even predict their future. Alas, even if astrology sometimes borrows the vocabulary and other tools of science, the myths it perpetuates are incompatible with science. And yet, at the outset, the astrologer uses irrefutable astrological data. The keystone of astrology is the zodiac. The zodiac is a set of 12 constellations, or groups of stars forming recognizable shapes in the sky. The constellations of the zodiac are placed in a vast band around the Earth. The band, called the ecliptic, is the rotating course of the Earth and planets around the Sun. Because of the Earth's annual movement around the Sun during the course of the months, the latter seems to gradually slide along the zodiac. So in one year, the star of day goes through each of the 12 zodiac constellations, one after another. As for the planets, they also move along the zodiac, albeit irregularly. About 2,000 years ago, based on these astrological events, the ancient astrologers defined a number of parameters that would affect human destinies. The sign is defined as the constellation of the zodiac where the sun was located at birth. The ascendant is the constellation of the zodiac which is rising to the east at the moment of birth. Finally, the aspects are the positions the various planets occupied at that time in relation to the zodiac and to each other. These parameters, still in use today, constitute the horoscope or sky chart, meaning the configuration of the sky at the precise moment and place of birth. The sky chart is established with utmost precision. However, it is when the astrologer interprets these astrological data that he leaves the realm of science. In order to accept astrology, one would first have to assume there exists a cosmic force capable of influencing human personalities and destinies from an extremely great distance. However, any such force would have to have strange properties. It would have to be mysteriously inoperative during the 9 months of gestation and only go into action at the precise moment of birth. It would have to be issued from certain stars, but not from others. Lastly, it would have to be sufficiently powerful to overrule all the psychological and social influences the newborn will eventually be subjected to during an entire lifetime. The existence of such an entity would not only be contrary to modern physics, but also to psychology. Astrology faces another difficulty. The sky is no longer what it used to be 2,000 years ago. This is due to the fact that the Earth rotates on its own axis and around the Sun, and is animated by a slow movement called precession. Every 26,000 years, the Earth's axis makes a complete spin, a little like a top. 3,000 years before Christ, the pole star didn't indicate the north. Alpha of the Dragon did. In the year 14,000, it will be Vega. Even though the motion of precession is very slow, it also has the effect of gradually shifting the apparent position of the sun in relation to the constellations of the zodiac. As a result, most people today are of the sign that precedes them. To take this fact into account, the astrologers redefined the zodiac. The zodiac thus no longer corresponds to the constellations, but to arbitrary subdivisions of the sky into 12 identical segments. So if the stars really do affect us, astrology cannot detect their influence. The main reason for the exclusion of astrology from the sciences is that its interpretations are based upon myths and not upon observations and facts. The founders of astrology believed that the planets were immaterial and immortal gods were endowed with human characteristics. Mars was the god of war, so they attributed the power to instill dynamism and activity to this planet. As for Venus, in the image of the goddess of love, it would have the ability to confer taste and sentimentality. Centuries later, astrologers still ascribe these amazing powers to the planets, even if we now know that they are simply masses of rock and gases floating about the universe. When scientists tell us that subatomic particles exist, we take their word for it. If tomorrow the Pentagon were to announce that a space probe had been hijacked by some extraterrestrial spacecraft, would we doubt it? On both sides of the looking glass, science and its twin, science fiction, take turns mystifying us.